Welcome to the Business Decision Modeling course. In this course, we'll introduce you to the various management science or business analytics techniques commonly used in business decision making. You will learn the logic of spreadsheet modeling and apply the knowledge to understand, model, and implement various business decision making scenarios. The focus of this course will be on the application of various analytical techniques and the IT tools required to understand and model real-world decision-making situations. In this particular lecture, we start by discussing the meaning of business decision modeling and explore its usefulness as well. The starting point will be to introduce you to the modeling approach in management sciences or business analytics. We describe how the models of decision problems differ in a number of important characteristics and how you should select a modeling technique that is most appropriate for the type of problem being faced. We then discuss how spreadsheet modeling and analysis fit into the problem-solving process. The other thing that we look at in this lecture is to discuss how the psychological phenomena of anchoring and framing can influence human judgment and decision making. These are important things in decision making scenarios that decision makers face from time to time. Finally, we describe the importance of distinguishing between the quality of a decision making process and the quality of decision outcomes. In other words, we look at, properties related to good decisions versus those that are related to good outcomes. So in this particular lecture, we'll focus on these 5 things. So the first one will be for us to understand the meaning of business decision modeling and why it is useful. Secondly, we will look at or introduce the modeling approach to decision making by highlighting what are models, what are the types of models that we actually use in management sciences or in business analytics. Thirdly, we'll focus on the characteristics and benefits of modeling. This is important to understand so that we know to what extent models can be used in decision making. Proceeding therefore, in the second slide, our emphasis therefore is to understand the meaning of business decision modeling. You must remember that the terminology has changed over time, and we are calling it business decision modeling. You may find that it is referred to as business analytics in some texts, but we will be using those terminologies interchangeably. In this slide, we want to emphasize that when you're looking at the meaning of business analytics, the emphasis is on decision making. And we must understand that by the very nature of life, all of us must continually make decisions that we hope will solve problems and lead to increased opportunities, not only for ourselves, but also for the organization for which we work. But we know that decision making is not always an easy task. It's not always easy particularly to make good decisions. Why do you think this is the case? We know that there may be a number of factors that influence the decision-making process. If you take an organization, for instance, an organization is faced, many organizations are faced with a very competitive environment. Some organizations operate in a highly data-intensive environment. Some organizations operate in an environment where the environment changes very, very quickly, right? And therefore, the environment becomes complex when there are so many factors that impinge or impact on the decisions that you have to make. So at any one time in such complex environments, you find that the decision maker is faced with numerous ways or various possible courses of action that they face for a particular decision that they have to make. And sometimes we can relate this to the context that we find ourselves in right now. The COVID-19 has forced organizations to rethink their business models, the way they do business, the way they deliver services. And many organizations that had not used IT before are now being forced to actually adopt IT. But the process of adopting IT is fraught with many decisions. There are many factors that impact adoption of IT in an organization. So it is these numerous possible courses of action that faces a decision maker that make it difficult, that make decision making to be difficult. So evaluating these alternatives and choosing the best course of action actually represents the essence of decision making. How to evaluate and to choose the various courses of action that face a decision maker at any one time. So because of these factors, decision makers either end up making good decisions and sometimes bad decisions. And hopefully as business decision modeling can help in that process of not only designing a proper decision-making framework, but also to result in a good decision. Despite the various factors that may face a decision maker. So we are just highlighting here that in any given situation, there are often numerous possible courses of action. So the gist of decision analysis is therefore to be able to systematically identify, evaluate, and choose the best course of action, despite the numerous options that are available to the decision makers. And for us to be able to do this, particularly in business analytics or within business decision-making modeling, we employ the use of computers to analyze the potential outcomes of decision variables. And you must think through, why do we use computers in decision-making environments? Why are they necessary? Because what the implication is that decision-making can take place, or decision modeling can take place without computers. We can design decision-making scenarios without necessarily using computers. But there's a reason why we use computers. Probably computers enhance the efficiency in the decision-making process, or even ensure that we are more effective in the decision-making process. So in the context of what we are going to do in this course, business analytics, we are mostly going to rely on electronic spreadsheets, such as Microsoft Excel. We know that since the inception of electronic spreadsheets in the 1980s, millions of business people have discovered that it is one of the most effective ways to analyze and evaluate decision alternatives. So the various spreadsheet packages that are available to decision makers are good platforms for decision modeling. And throughout this course, we'll be using or applying spreadsheets in different scenarios so that we see how decision modeling takes place. Therefore, today, we know that electronic spreadsheets actually provide the most convenient and useful way for business people to implement and to analyze computer models. So as we talk about business decision modeling, our emphasis is on computer modeling, how to use computers to model decision-making scenarios so that decision makers can make much more efficient and effective decisions of the various possible courses of action that they face. Indeed, most business people would probably rate the electronic spreadsheet as their most important analytical tool. Of course, apart from the brain, we know that human beings, use their brain. We still don't have a computer that is better than the brain. Maybe we'll get there. But apart from using the computer modeling approach, the human brain is not, we don't underrate the human brain, because decision making is still done by the human being, even though the modeling is done by the computer. So using a spreadsheet model or a computer model, a business person can therefore analyze various decision alternatives before having to choose a specific plan for implementation. I think with that background, we can then define what a business decision modeling is, or business analytics, right? And also note that there are various definitions of business analytics, and depending on the textbook that you read, you'll get a different flavor of the meaning of business analytics. But we will give you a generic, definition or conceptualization of business analytics that that can apply in almost all situations. And if you look at the course text definition of business analytics, they look at it as a field of study that uses, number one, computers, statistics, and mathematics to solve business problems. So they try to underline the key disciplines that define the field of business analytics or business decision modeling. So we have computers coming in to help in making sure that the modeling process and the decision-making process is efficient and effective. So when we talk about electronic spreadsheets, then they fall within the computer discipline. So electronic spreadsheets such as Microsoft Excel are part of the tools that come within the terminology of computers. And then they also highlight the importance of statistics, right? Remember that statistics is the collection, analysis, presentation, and interpretation of data. So by merely having statistics there, the emphasis is that in business decision modeling, there is a data aspect that we need to take care of. We need to be able to identify the data that we need for decision making. We need to be able to collect that data. We need to be able to analyze that data. We need to be able to present information about that data, and eventually to interpret the data. So computers have their role, but there's the aspect of data that we cannot model decision making from a management science perspective without thinking about the data and what is required and how data impacts decision making. Lastly, mathematics. And in mathematics, we're looking at it from a broader perspective, that mathematics provides not only the structure, order, and the relationship between the various aspects that we are trying to model. So the kind of modeling that we actually emphasize in business analytics employs mathematics by recognizing that you should be able to structure that problem that you have. There should be some order, and then there should be some relationship between the variables or the possible courses of action that a decision maker faces. So from the text that we are using, we emphasize the role of these different disciplines, that business analytics is a field of study that uses computers, statistics, and mathematics to solve business problems. And by business problems, we do not just mean commercial sector enterprises. We talk about organizational problems in general, whether they are in the private sector, whether they're in the public sector, whether in the non-governmental sector. So the problems that they face, so long as that problem can be modeled by using techniques of business analytics. And these techniques rely on the disciplines of computers, statistics, and mathematics. Now, we also know that business analytics has various stakeholders, and there are industry stakeholders, there are those who are in academia, but there is also business analytics or management science is also associated with the Institute for Operations Research and Management Science, or INFORMS. So it's one of the largest professional associations that for business analytics or management science or decision sciences. And for them, they define analytics as the scientific process of transforming data into insight for making better decisions. So even in this definition, we see the emphasis of data, which is emerging from statistics and the structure that is provided by mathematics, right? And when you talk about, and this data must be turned into insight for making better decisions. Now, the discipline that comes into effect in terms of making the data into insight is the tools that are provided by the computing discipline. So when you talk about big data analytics or business analytics or machine learning, then this come into play because their role really is to be able to transform the data into insight for making better decisions. So from a historical perspective, and Informs as an association has played a big role. The meaning of business analytics is linked to a scientific process of decision making, and there must be data that need to be transformed into insight. So obviously, if you cannot structure your problem, or if there's no data available to be able to model or to be used in that decision, then that problem is not amenable to business analytics or to management science techniques. Now, also take note that there is considerable overlap in terms of terminologies. Since its inception, terminologies have been changing. Historically, business analytics is linked to what is known as operations research or operational research, depending on whether you're talking about it from a UK or English perspective or from American perspective. The terminology that they use may change. So you find that operations research is very American, while operational research is much more UK based. However, we see the origins of operations research being used a lot in the military, particularly in the Second World War. So operations research was used a lot to handle the logistics of warfare during the World War, moving huge armies, moving resources from one place to the other, how to route these resources through various territories. Some of the territories are enemy territories, so there must be decisions about which route to use based on the conditions on the ground. So the terminology of operations research can be linked to the use of these techniques, particularly during the Second World War. However, after the Second World War, as these techniques were adopted in organizations, in businesses, in government, then the terminology started changing more towards management science, because these techniques are mostly used to aid decision makers, and these decision makers are managers. So we see the terminology of management science, becoming much more popular post the Second World War. Other terminologies that are associated with it could be decision sciences as well. So in most of the textbooks that you will be coming across, many of them, most of the older textbooks still refer to it as management science. But there are also other texts that are, refer to the discipline as operations research or operational research. Much more recently now, we now talk about business analytics, which is much more common, and business analytics is much more broader than, for instance, the machine learning that is mostly associated with the computer sciences. So in our context, in terms of to enhance your understanding, we can adopt the text definition that this is a field of study that uses computers, statistics, and mathematics to solve business problems. And overall, these three actually provide the scientific process that helps in transforming data into insight for making better decisions. So obviously, apart from defining what it is also important to look at the usefulness of business analytics or business decision modeling. Now, business analytics has been used in various areas. For instance, and here we just provide a sample. And as well, the text that we use for this course has various examples. Some of the examples that the textbook has used are from INFORMS, the Institute for Operations Research and Management Sciences. Every year, they try to document how business analytics is being used by organizations. So if you look through the text, you will see additional applications of business decision modeling or business analytics. Here we highlight, a number of them, but also remember that as we go through the course, the topics or the modules will be highlighting these applications of business analytics. And the first one you can think of is, how restaurants make hamburgers. For instance, many of you are familiar with Burger King. So if you go there for breakfast, they have their own specific products, whether it is breakfast, whether it is lunch, whether it is dinner. Now, in the composition of those products, the restaurants or the companies must typically want to minimize the cost of producing, a particular product so that they make more profit. I think most organizations think that way. So breakfast will have a number of things. Maybe there is some meat, there's some bread, there's some tomatoes, etc. To determine the product mix, in other words, the components of the product or the different elements that make up that particular product, we find a tool such as linear programming has really been used in this area, in what is called a product mix problem, such as producing hamburgers in restaurants or even at home. When you're making breakfast, you think about, I want to have breakfast with bread, I want to have breakfast with eggs, I want to have breakfast with tea. All these things cost money. And for you, you want to be able to minimize how much money you spend, for every breakfast package that you prepare for yourself. And so we're saying that, linear programming has been very, very key in product mix problems. The second one, I think, which is very useful and is used a lot in airlines. If you think about how airlines operate, they do a lot of scheduling or scheduling of crew, aircraft crew. An airline operates, for instance, between Johannesburg to Durban or from Johannesburg to Bonn in Germany. Now, every airport has its own ways of operations. And for every airline that lands in an airport, they need to have some turnaround time to be able to, for instance, change crews, change passengers in a particular airport and proceed to the next stop. So we find, again, integer programming, which is a type of one of the techniques of business analytics, is used a lot by airlines in terms of scheduling of crew members that are operating for the airline. The other example is something that maybe all of you use, GPS, the global positioning system that we use, for example, to find the directions that we want to go to. Right now, obviously, in the design of the GPS, it allows you to decide or to choose which is the shortest path that you want. Ideally, if you're a rational decision maker, you want to be able to choose the shortest path. You wouldn't want the longest path, because the longest path will be expensive or will be much more costly. For instance, you'll use more fuel. If you're walking, you will be tired if you choose the longest path. So the GPS is embedded with, some of the GPS are embedded with some of these techniques of business analytics, such as the shortest path method for determining what is the shortest distance for you to travel. We also have other applications. For example, in transportation, we have transportation models. If you're a transport manager of a company, a bus company, for instance, Obviously, you must be in a position to determine what are the most efficient routes, what are the most efficient routes for the buses that you have. How do you schedule these buses? So you may find within a transportation model there's a mix of different techniques that can be used to aid in uh, modeling transport routes, for instance. So you find there are transportation models that can be used. Sometimes you can also use simulation models, because simulation allows you to determine, what if scenarios. What if there's a traffic jam caused by something on the road? What do we do? So by using simulation, you are able to advise drivers when situations occur, the change of routes or the change of routes, depending on road conditions. Of course, we have also seen a lot of the use of business analytics techniques in policy planning, for example, decision analysis, and we will see many of them as we go on. So from this, you should get a picture of the extent to which business analytics, or what we're calling management science, or what we're calling operations research, is used in various scenarios, whether it is linear programming in products mix problems, or scheduling of crew members in airlines, or the use of the shortest path in GPS systems. We also have transportation models or simulation models in developing transportation models, as well as in policy planning. I think the next thing now would be to try and understand, when we talk about a model, we say that in business decision modeling we'll be using computer models. Therefore, it is important to understand what is the meaning of a computer model. And formally, to define it, you need to understand that the models that we use in this course are mathematical in nature. So we'll be looking at how they are related. What are the mathematical relationships? If you recall what I said about the meaning of one of the disciplines is mathematics that is used in developing business decision models. So the formal definition of a computer model is that it is a set of mathematical relationships and logical assumptions implemented in a computer as an abstract representation of a real-world object or phenomenon. Right? So a model is a representation of the real world. This is what we need to need to pick out from it, that it is a representation. It is not the real object, the real world object or phenomenon. It is a representation. So obviously with representations, there are some details that may be missing within that particular object, that particular representation. And we are emphasizing it as a mathematical relationship because there are different types of models apart from computer models, and we'll see some of them as we go on. So, for example, when you talk about the spreadsheets that we are going to use in this course, that's an example of a computer model. And spreadsheets provide the most convenient way currently for business people to build computer models, not only because they are available with your computers. Once you have a computer with Windows and Microsoft Office, you know that the Excel is there and you can use it without any charge. So spreadsheets are commonplace on most computers. That's why they are convenient. And therefore, they have become a tool of choice for today's managers. It has been used a lot for facilitating decision-making processes by making it easier to play out different scenarios, such as what-if scenarios or sensitivity analysis. So it is important that we emphasize this, that the models that we deal with in this course are computer models, which respect the mathematical relationships between different variables. So the next thing that I want us to look at is, given this definition of what a computer model is, what are some of the examples of computer models that you find, within decision-making scenarios. This may include a number of them. The first one would be, linked to the definition that we have earlier, what are called mathematical models. And mathematical models could be equations. Many of you have come across equations during your training over time. For example, in business, we know that an equation such as for calculating profit is linked to revenue and expenses, so that profit is equal to revenue minus expenses. But another way of expressing that mathematical equation would be to say that profit is a function of revenue and expenses. So here we are not including the relationship, but we are just recognizing that there's a functional relationship between revenues and expenses. And even without using the actual words for those things that we want to determine, we can decide to use letters to represent those terminologies. For instance, we can use Y to represent profit, F to indicate the function or the functional relationship, while X1 can be used to represent the revenue aspect, while X2 to represent the expenses aspect. So this is an example of mathematical model, and we'll see many of them as we go on. Another example of a model could be the various algorithms and what are called discrete event processes. Basically, these are just a structured set of rules of steps to follow. So in business analytics, there are various algorithms that have already been developed. So when we talk about, for instance, in data mining, we have cluster analysis. Within cluster analysis, there are several algorithms or procedures for doing that process of cluster analysis. So if you're faced with a decision where you're required to look at various clusters, then you have to implement the cluster analysis algorithm for you to be able to understand the data that you're going to use for decision making. So again, these algorithms are also considered as models, as decision-making models. So when you talk about clustering algorithms or classification algorithms or association rule mining algorithms, these are just examples of algorithms. Regression analysis is a form of algorithm that can be as an example of a model, of a computer model. Another example could be queuing models or even waiting lines. So when you use simulation, you can use simulation to understand the nature of a queue. If you go to a bank, normally you find a queue, right? And depending on the behavior of the queue, the manager of the bank may decide to increase the number of bank tellers so that people do not stay for so long in the queue, so that their waiting time can be reduced. So by increasing the number of servers or the number of tellers, they are impacting on the waiting line, particularly the characteristic of waiting time. So when you start doing simulation, you are applying it on system behavior, such as where there are queues or where there are waiting lines. And customers do not want to wait for too long. So organizations work very hard to determine what is the average waiting time that can still make customers satisfied even though they are waiting. So sometimes when you go to a bank, you may find that they have a TV, and that TV is just meant to keep you busy so that you don't get tired, you don't get dissatisfied with waiting. So those strategies can only be implemented after you determine, for example, the nature of the queue, as well as, for instance, what is the average waiting time that can still make the customer remain satisfied while waiting for service. There are also a number of statistical techniques. All these statistical techniques are examples of models. And I think as we go further, we'll see some of these examples. In the next slide, we simply provide an example of a mathematical model. I think we've talked about Profit can be is a function of revenue and expenses, or you can also, as an expression or as an equation, profit is equal to revenue minus expenses. And these kind of expressions drive us to something else, that when you talk about dependent variables and independent variables, the dependent variable is that particular issue that you want to resolve. For instance, commercial organizations are interested in profit, and they want to be able to determine profit, after a certain period of time. There's always a period involved. And if you have identified that the issue that you want to determine, which is profit, is a function of revenue and expenses, it means you need to be able to get or determine what is the data, where is the data for revenue and expenses that you can use to determine the dependent variable, which is profit. So these values related to these variables of revenue and expenses are what are known as the independent variables. In other words, the independent variables influence the behavior of the dependent variable. Therefore, in the equations that we have above, or in the functions that we have in this slide, profit is therefore a dependent variable, whereas revenue and expenses are independent variables. Obviously, these concepts can be represented using letters such as X1, X2, or X and Y, or ABC. The choice typically is up to the modeler. What kind of letters do you want to use to represent your independent and the dependent variables? And as we continue, we'll see that the way we structure these mathematical models, they align very well with how electronic spreadsheets work. So that's why we are going through this, to understand the structure of mathematical models and how they will be aligned to the electronic spreadsheets that we normally use. So generically, any mathematical model can be represented, using letters. For example, y, which is a dependent variable, could be a function of various things, of various variables, x1, x2, up to xn. All right, and the f denotes some functional relationship, given the definition we had earlier. In other words, what's the relationship as you seek to determine what y is? How are these variables related to each other? For example, when we are determining profit, we know that profit is equal to revenue minus expenses. We saw in the previous slide. Right? So when you express it in the form of a function, you are not explicitly identifying the nature of the relationship between the variables. So this is separate from maybe an equation where you will have to identify the nature of the relationship. So the f function therefore defines the relationship not only between the independent variables, but how the independent variables are related to the dependent variable. So this is it is this form when you must be able to express the problem that you are facing in this form, where y, the dependent variable, is a problem that you want to solve, while the x1, x2, up to xn are the independent variables that affect the dependent variable. So all this can be expressed, generically, as I've indicated above, and it is this models that are then applied or used within electronic spreadsheets. So that most spreadsheets, in a spreadsheet, you'll have to have a cell where you input values that are associated with the dependent variable, as well as those that are associated with the independent variables. That's why we say that most spreadsheets have input cells representing, the X values, or those variables that you want to determine, to which the mathematical functions are then applied to compute what the dependent variable is. So there must be some data, but what's the relationship between the data and the dependent variable that you want to determine? An example would be, for example, when you want to purchase a car, and you want to pay every month for that car that you're purchasing. For the buyer, their interest is therefore this monthly payment that you have here. And as much as possible, you want the monthly payment to be minimum. Everybody, any rational buyer want to be able to do that. How can I pay the least amount every month for this particular car that I want to purchase? So this monthly amount that you want to pay is your dependent variable. It is your Y. And this Y is affected by a number of things. There's the actual purchase price. Obviously, this amount is determined by how much is that car costing anyway. What is the total cost of that car? Is it 100,000 rands? Is it 200,000 rands? Or is it $300,000? Right? So that would be one of your first variables, X1. And then for you to be able to minimize this value, the monthly payment, most car sellers can reduce this value. For instance, if you have a down payment, obviously it is high if you don't have a down payment. So this value will go down if you have a down payment. Like in this case, this person is putting down $2,000. So this would be our X2. Remember that there would be a buyer who does not have this down payment, so their monthly payment will be different. Also, this value can go down if you have a trade-in. So if you have an old car, you can take it to the seller and they can exchange it. And they'll put a value on that old car. Typically, you get a raw deal for it, but at least it is helpful in reducing your monthly commitment to the car seller. So with these two variables, X2 and X3, you see that the amount that need to be financed has reduced from $18,500 to now $12,500. Right? And if the term of the loan is 4 years, the term of the loan is another variable, X4. And the annual interest that you have to pay because you owe the money, X5, is another variable. Right? So you see that, a mathematical model like this, expressed generically in this form, where Y is a function of various variables such as X1, X2, up to Xn, can similarly be captured in a spreadsheet in this format. I mean, you are familiar with spreadsheets. We have captured, here we have X1, X2, X3, X4 to X5. All right, so our last value here is the N is X5, while our Y is the monthly payment that we need to commit to the seller every month. So this is why we are saying that spreadsheets are very, very, very useful in capturing mathematical models, so that we are able to manipulate the data and determine what is the best course of action for a decision maker faced with a problem that can be modeled in the format that we have in business analytics. But we'll see more of this action. I mean, the whole course is based on how to model these decision scenarios by using spreadsheets, electronic spreadsheets. As a form of introduction, it is also important to understand or to answer the question, what are the key categories of mathematical models that we have in business analytics or business decision modeling? And again, you will see these terminologies used a lot when you're reading books on machine learning. They will have these categories. When you're reading books on data mining, they'll have these categories. What I want to emphasize here is that when you talk about the term business analytics, it's much, much broader than, terms such as machine learning or data mining. Data mining techniques or machine learning techniques are found within business analytics. So the categorization that we use here takes this into account, that business analytics is much more broader than some of those terminologies you find in everyday usage. And from this slide, we see that there are three main categories, and it's important to understand the difference between these categories of business analytics. We have what are called prescriptive models. We also have what are called predictive models, and we have descriptive models. And if you look at the table, the core characteristics that differentiate between these various categories are related to particularly the knowledge that the decision maker have of either the functional relationship between the variables. That's what we have in the first column of what is the form of the functional relationship. Does the decision maker have knowledge about that problem, and what kind of knowledge does the decision maker have about the problem that they want to solve? Then the second aspect relates to whether the values of the independent variables are known or unknown, or there is uncertainty about the values that you're using for the independent variables. Then the last column basically identifies examples of techniques for each of the categories. So when you look at the first category, which is prescriptive models, what is clear is that the functional relationship must be known or must be well defined. And as well, the values of the independent variables should either be known or should be under the control of the decision maker. So when you look at prescriptive models, those two must be clear. The form of the functional relationship must be known, as well as the values of the independent variables must be known. If we go back to our earlier example of profit is equal to revenues minus costs that we looked at earlier, right? We are saying that for you to be able to solve a problem where you want to determine what profit an organization is likely to make in the future, then it is important to understand the nature of the relationship between revenue and expenses. And from this expression, we can see that the functional relationship of these variables is that you must subtract expenses from revenues. That therefore captures what we are calling the form of the functional relationship. It is known and well defined that for you to determine profit, you should minus costs from revenues. Secondly, that you must have or you must know the values of the independent variables. If you do not have data, for instance, on what are the unit costs of the products you're making and what is the selling price or what is the revenue for each of the products, then you cannot undertake prescriptive models. But if you have those values, for example, you may know that to produce product X, the selling price is 300, while the cost for producing that product X, the selling price is, the cost is 100. So if you know that, then you are able to carry out what we are calling this prescriptive, you can undertake prescriptive modeling. And there are various examples. And as we go through the course, we'll see how linear programming is used. We'll also see how network modeling is undertaken. Integer programming are examples. Critical path method or CPM, goal programming, economic order quantity, as well as nonlinear programming, which is different from linear programming. So the emphasis I want you to understand is on these two aspects for you to be able to determine, prescriptive models. And prescriptive models provide a way of saying what will happen in the future, what can we do in the future, what kind of profits do we expect if we produce X number of products and Y number of products. So we are talking about prescriptive models provide solutions to the decision maker by telling the decision maker what actions need to be taken, particularly in the future, given the information about the form of the functional relationship as well as known values of the independent variables. The second major category are the predictive models. And I would say that a lot of the statistical models actually fall within the predictive models. And in this case, you normally find that the form of the functional relationship is either unknown or ill-defined. And particularly if you look at statistical studies, they are mostly focused on trying to determine what is this value of Y if we know if we know the independent values. So you can see under predictive models, the form of Y is ill-defined or unknown. So when you collect data of the independent variables, you want to be able to make this functional relationship clear or known or better explained. So under this category, we find various business analytic techniques such as regression analysis. We know that regression analysis is used for prediction or explaining the nature of the functional relationship between, for instance, Y and X values. Time series analysis, another example. Discriminant analysis, another example. Neural networks is also another type of predictive model. Logistic regression is another type of predictive models. Affinity analysis, as well as cluster analysis. Now, I want you to know that some of these, because they are studied or they are covered in statistical units, we are not going to cover all of them, but we'll take a sample in each of these categories so that you are familiar with what are the different business analytics techniques in each of the categories, whether it is prescriptive models, predictive models, or even descriptive models. Now, when we come to descriptive models, here the form of the functional relationship again is well known, so it's almost similar to the prescriptive model here. But the values of the independent variables are unknown or are not under the control of the decision maker. So obviously, if you do not know which are these variables that are impacting on your dependent variable, it's not very easy to either prescribe or predict the behavior of that dependent variable. That's why in terms of descriptive models, they rely a lot on simulation, because you are uncertain about the values of the independent variable. So if you're talking about the profit equation, where we have profit is equal to revenue minus expenses, it means that we don't have information about revenues, we don't have information about expenses, right? But we know the functional relationship between revenue and expenses in determining profit, but we don't have the values of the independent variables. That's why you use simulation, for instance, or queuing models, or inventory models because you don't have information about the independent variables. These are the major categories of mathematical models that you find in business analytics. And this categorization is found in many, many textbooks and is also in line with the categorization that is adopted by the Institute of Operations Research and Management Sciences. If you go to the next slide, in fact, in the categorization by informs, they actually indicate that the mathematical sophistication increases as you move from descriptive modeling to prescriptive modeling. So Prescriptive models are much more mathematically sophisticated or advanced compared to some the descriptive models. So it's a continuum of sophistication as you move from the top to bottom. As well, the insight that you can gain by using prescriptive and predictive modeling is much more than what you can gain by using descriptive modeling. And they highlight some of the key questions that are linked to these categories. For example, when you talk about descriptive models, the key question that the modeler is actually asking is, what happened? So obviously, when you start talking about, when you ask such a question, you are relying more on historical data. You do not know, you don't have much to go forward in terms of what is in the future. So you use historical data to do your analysis to be able to make certain decisions. Right? That's what we talk about in descriptive modeling. You prepare and analyze historical data, and from the historical data that you have, you can identify then the patterns from the samples that you use in your analysis, right? So a lot of the techniques that are related to reporting or visualization or data modeling are actually linked to descriptive modeling. Now, when you come to predictive modeling, then the key question that the modeler asks is, what could happen? What happened is linked to descriptive, but what could happen is predictive in nature. This is a very different orientation, or a very different question, because when you ask what could happen, your interest is to be able to predict future probabilities and trends. What is the future possibilities that faces the decision maker or faces the organization, right? So the techniques that you use then help in determining what are these future probabilities or future trends. And with this, then you're able to determine the relationships in the data that may not be apparent, for instance, when you carry out descriptive modeling. So the techniques that we have seen earlier, for instance, statistical and simulation forecasting. Simulation can be used in a number of these categories. Statistical and simulation forecasting techniques, data mining techniques can be found under predictive category, as well as pattern recognition techniques. And then lastly, the third category, starting from bottom to top, is the prescriptive. And the question that is asked here is, what should we do? So very focused on the future. What should we do? And in asking that question, you find that the modeler focuses on identifying and evaluating new ways to operate. What is the likely scenario in the future? How can we be more profitable in the future? What are the different product mix scenarios that we can experiment with to be more profitable in the future? So we're talking about what should you do in the future. And then this type of modeling targets what are the business objectives. If the business objective is to maximize profit, then you need to model what are the variables that impact on profit. Is it revenue and expenses? What is the nature of the relationship between revenue and expenses? Right. So if profitability is the objective, then your interest is in how to model those the variables and the functional relationship between those variables and the profit objective. It could also be to minimize cost, because some organizations, apart from focusing on maximization of profit, they focus on how to minimize costs. And we'll see various scenarios of how these models are used in either solving maximization problems or even solving minimization problems. And also, these models try to balance all the constraints. So whatever decision situation that is facing a decision maker, there will always be constraints. If you're determining the profit of an organization, you don't have unlimited resources. Decision makers are faced with limited resources. The constraint could be, for instance, the budget, right? Different departments or even the organization as a whole does not have an unlimited budget. So even as you are determining profit, you are constrained. There are various constraints. It's not one. They could be one, it could be more. So the prescriptive models try to balance all these constraints in determining which is the best course of action to realize the business objective. All right. So all these are linked to the techniques that you find under this category. For instance, optimization techniques. If an instance of optimization is linear programming, which focuses on the relationship that are linear in nature. So when the dependent variable and the independent variable has a relationship that is linear in nature, then the optimization technique that is used there is linear programming. But sometimes the relationship between the variables is non-linear in nature or curved in nature. So you find techniques such as systems dynamics are then used in those scenarios to solve problems that are non-linear in nature. So we see the categorization that are found in most generic textbooks is well in line with this categorization that is adopted by the Institute of Operations Research and Management Sciences. The next thing that we can look at is how to use models. We have seen what a model is. We have seen the various categories of models that are found in business analytics, and we have seen that there are three main categories. That they are prescriptive, they could be prescriptive, predictive, or descriptive in nature. But we need to know that models have their own limitations, and therefore how you use them is important in decision making. So in using models, you need to consider a number of things. Number one, a modeler should not just accept an answer without further analysis and questioning. You cannot leave decision making to the computer. The decision maker must come in and ask questions of the answers that the computer is giving. Right? That's why we're talking about don't accept an answer without further analysis and questioning. That's why the additional techniques such as sensitivity analysis that forces the decision maker to consider different options. Then the other thing a modeler needs to take into account is that the computer model that you design for a particular problem situation is only one of the tools used in decision making. So there are many other tools that are used in decision making. And for example, just the brain of the decision maker is important. The role of the human being must always be recognized. So the model has its place. So a model is only one of the tools that is used for decision making. Thirdly, if the answer is unacceptable, the answer generated by the model, the reasons for unacceptability should be spelled out and incorporated in a modified model. Therefore, documentation as you design a model is important so that if there are challenges or there are reasons why the models cannot work, spell them out and let the stakeholders that you are interacting with know why the model is not acceptable. Number 4, you must also remember that an acceptable answer is only an option, because there could be other options available that you have not considered or that you do not know about. Remember, as we looked at the various categories, we were looking at the form of the functional relationship, whether it is known or unknown, and whether you have the values of the independent variables under your control. There may be independent variables that are not under your control. So when you model a problem, the solution that you get are only related to the constraints that were under your control. But there may be others that are not under your control. So that's why we have the highlight there that an acceptable answer is only an option. There could be others that you didn't consider because you didn't have all the facts. And then probably another consideration is to consider that by successive questioning of the answers and altering the model, it is possible to clarify the options available and obtain a greater understanding of what is possible in real life. Right? This is required of any modeling exercise, that you must continually question yourself, ask yourself, is this making sense? What if I change this variable? How does the model change? Is it much more realistic if I change this variable or not? These are some of the considerations you must keep in mind when you are modeling. I think the next thing we have to look at is, in terms of the key aspects of this model, is what are the characteristics of models? And we summarize them in two ways in terms of characteristics. That models must be simple. It's a key requirement in modeling, that when you are designing a model of any situation, any problem situation, the model must be simple. Because they're simply versions, they're simply abstractions, they're simply representations of the reality that exists. So, and that is the reason you are modeling anyway, because you are not able to use the real situation in totality to decide. So you design a model to represent that reality so that you are able to make the decision. So if the model is not simple, then you are complicating the decision-making process. For example, take an example of in the aerodynamics industry. Those who manufacture planes, those who whether it is Boeing or whichever type of model that you're talking about. When they are making the plane, there are many things that they do not know about, right? That's why they build models of planes, a simplified model of a plane, so that they can use that model to make decisions related to different aspects of the plane that they are actually building, right? So the actual model, the actual plane model that they use is a very simplified version of the actual plane. The actual plane is a very complicated object, right? That's why we are emphasizing that, models must be simple so that they can enhance decision making, or so that they can be relevant in decision making situations. The other key characteristics of models is that they should be valid. When you talk about validity, validity is about the model being acceptable, right? And you say here that a valid model should accurately represent the relevant characteristics of the object or the decision problem. But when you talk about accuracy, it is accuracy to who? The decision makers must accept the model. Is that model accurately representing their situation, right? And that's why we talk about a model must be validity. And the example we give there illustrates this point. If you look at the use of maps, maps are very simplified versions of the actual reality, which is the Earth. You know that the Earth is very complicated. We don't even know whether it is round or flat. They came from saying the Earth is flat to round. Now they're even talking about the Earth being flat again. And we use maps to actually represent this complex phenomenon. And even the maps themselves can be very expensive. You just take a map of a suburb. A map of a suburb only is just representative and does not include many things, right? Maybe the people who are walking there may not be on the map, or a wheelbarrow that is found outside the house of a resident may not be captured by the map. That's why we say that, the actual model is a simplified version of the reality. But that map, whether it is simple or not, must still represent that reality. That's why we talk about validity, whether it is acceptable to the stakeholders to the stakeholders or not. Given that introduction in terms of the characteristics, let us now look at the key benefits of modeling, right? And these benefits derive from those two characteristics that, first of all, must be simplified as a representation of the actual phenomenon, and that it should be a valid model. The first aspect is that modeling enhances real understanding of a situation, right? So that, when you use modeling, it can reveal maybe hidden relationships that are within the system that you are not familiar with, or that you cannot see upfront. And as well, it enhances real understanding because it forces modelers to do or undertake formal analysis. For instance, by looking at what are the assumptions in this problem situation, and what is the nature of the relationship between the variables that we find in this particular problem. So by forcing the modeler to perform a formal analysis, it enhances their understanding of the problem situation. And obviously, one of the key aspects of modeling is that it encourages experimentation, right? And you can do the experiments repeatedly so that your understanding of the situation is improved, right? And we also see that there are a variety of different models for the same problem. For instance, in the same problem, you can use a queuing model as well as a simulation model to try and understand or to model the complexity of that real situation. So definitely modeling helps in understanding or improving understanding of a problem. The second major benefit is economy, that obviously it is less costly to do modeling from a model or to make decisions from a model than sometimes using the actual phenomenon, right? I mean, if you're a company that makes light bulbs and you want to test the durability of the bulbs, you do not want to experiment on the real bulbs because you will be breaking them. Rather, if a model is built of the bulb or a simulation of the durability of the bulb is used instead, then you are not destroying, it's not costly, you are not spending money, right? Or rather, it's less costly than actually experimenting on the durability of the bulb by actually breaking the bulb, right? So it is much more less costly to analyze decision problems using models than sometimes doing it on the actual objects that you are making decisions on. Therefore, it is less expensive and also less disruptive than experimenting with the real world system. Now, we also know that there are many decision situations that are complex, and sometimes modeling is the only way of trying to understand the situation. So in that sense, then modeling allows for timeliness in decision making. So you are able to deliver information more quickly than when you are trying to make decisions on the real world phenomenon itself. Right? So if you're designing a plane and you have developed a physical model of the plane, the physical model is much smaller, only focuses on the important characteristics of the plane, and you're able to make design decisions based on that physical model. Right? So it's much more quicker rather than building a huge plane. It's going to be costly, but also time. It will take a lot of time, not only to build the actual object. And after building it, you may realize you made a lot of mistakes. That's why it's important, apart from the timeliness aspect, is it feasible to use models? Because there may be situations where modeling is the only feasible way to understand the situation and make decisions. That's why we talk about feasibility. It is used to do things that would be impossible to do in reality. If you have a new model of a plane surely you cannot build the plane first. You can only build the model first and use the model to make changes on the plane as you're building it. So modeling can be the only feasible way in some scenarios to understand the situation and make decisions regarding that particular problem situation. We have also seen how modeling can help in better insight and understanding. So obviously, if you have more insight, your understanding is improved, and therefore you're able to improve your decision making. And I think lastly, which is very key, is that by using modeling, decision makers are forced to adopt a systematic approach so that their rationale for decision making can be understood by the different stakeholders that they are interacting with. And apart from that, models, by using this systematic approach, models force a consistent, systematic approach to the problem. And they also force managers to be specific about what are the constraints and what are the goals. So they must decide what is the goal of this decision and which constraints impact on this particular goal that we want to realize. Otherwise, if this systematic approach is not adopted, then decision making can be a little bit haphazard, and therefore modeling the systematic approach that is used in modeling is very useful in understanding explicitly what are the goals of the decision making situation and what are the constraints that impact the decision making that is facing the decision maker or the modeler. Now, apart from these benefits, there are also a number of disadvantages, right, which I want to highlight before going to the problem-solving framework. Sometimes you may find that models may be expensive to develop and test, particularly in complex scenarios that may require different modeling techniques to be used. Right, so this is very context dependent, depends on different situations. So it could be expensive to develop models. Sometimes it may require the collection of data, and the process of collecting data may be expensive in some situations, and therefore you may find in some contexts that models may be expensive to develop and test. Sometimes models may be misused and also misunderstood because of their complexity. And this is a very common problem in modeling. If you look at the current situation that we are facing with COVID, you may have noticed that the decision makers, whether they are the minister or the president, they are actually relying on some of the models that you'll come across here. Some of them are specific to epidemiology. Now, if you look at some of the models that they're using, the range of possible actions that they suggest are so wide that, the interpreter or the decision maker who interacts with the model determines how to use that particular model, given the range of possible actions. So, if you are a decision maker who is pessimistic, you may be going for a very low value, while for optimistic decision makers, they may be going for very high values. So that's why we say that, sometimes models are misunderstood or misused, and it depends on the decision maker. For example, linked to the current pandemic that we are having, if you compare with some of the models that were used to determine the number of deaths, they provide a variety of values. Sometimes, even historically, the way they have used these models, the values can range in terms of millions of deaths, right? So it depends on who is actually using the model. Number three, in terms of disadvantages, models may also downplay the value of non-quantifiable information, right? Because in business analytics, our emphasis is on quantifiable information. So if you don't have quantitative data, then you can't model. By insisting on quantitative data, it means that we are ignoring other factors. Some of them may be qualitative in nature that may impact on decision making. And therefore, we need to be cautious that models downplay the role of qualitative data. And lastly, sometimes modeling oversimplifies the variables of the real world. And, if you look at some of the challenges that Boeing, the airplane manufacturer is facing, for them to develop or for them to build the airplane, they simulate. Sometimes they have flight simulators to simulate the behavior of the airline in the air. But simulation sometimes is not does not really capture what happens in reality. So sometimes those simulated scenarios can oversimplify the actual situation. And therefore, once you actually implement the model, then you end up with the kind of accidents that we have seen before, for instance, in the airline industry in the recent past. The other thing that is important in the introductory lecture is to sort of come up or present to you an overall problem-solving framework that is used in business analytics in general. Right? This is a very generic framework that captures the process of a business decision modeling. And there are 5 key phases of this problem-solving framework, right? Starting with identification of the problem, and sometimes, and we are also not just talking about problems, there are also opportunities. So you're either talking about identifying the problem or opportunity, and the text refers to this as opportunity. So when you're looking at a problem situation or a business decision modeling situation, you can either refer to a problem or an opportunity. And sometimes what you refer to as a problem may be an opportunity to other decision makers. Again, if you look at the COVID environment that we find ourselves in, obviously it is a problem that is affecting nations, it is affecting individuals, it is affecting communities. But on the other hand, COVID-19 has also provided an opportunity to some businesses. There are businesses that have come out of nowhere to be able to produce, for example, personal protective equipment. There are even fashion houses that used to produce, fashion or clothing. They have changed their production process to produce PPE equipment. So the problem has become an opportunity to them. Therefore, as you are modeling, you should not just look at it in terms of a problem. What is the other way? Can it be an opportunity as well? So that is the first phase, identifying the problem or opportunity. The second phase then would be to formulate and implement the model. Problem formulation phase is the core of this course. That as when you identify the problem, how do you formulate a solution so that that particular formulation is amenable to a business analytics technique. So that is the core of the second the second phase. So throughout our discussion in this course, our goal will be to build models that are able to assist managers in making decision problems. So obviously the first step is to identify that problem or opportunity. And then secondly, you should be able to, we should be able to formulate the problem adequately so that it is amenable to business analytics techniques. And in our case, we'll mostly be using electronic spreadsheets. How do we formulate these problems or opportunities in electronic spreadsheets, specifically using Microsoft Excel? After formulating and implementing the model, then obviously you should carry out some form of what-if analysis. So we talk about you should analyze your model. You've come up with one scenario, right? Try and consider what if different factors change, or what if the different values of different factors change? How does the model change, right? So we talk about analyzing the model by considering different what if situations. The fourth phase, after considering various possibilities, is to test the results. Before you implement the solution, you must test the results, because remember, as you analyze, you may realize, I have these four various courses of action, but we think that alternative number 2 is the best course of action that we should carry out. You then need to implement or test the results of these different alternatives. So if you find that alternative number 2 has the better results, then you then implement that model in reality, right? Implementation is one of the key challenges in this process. And this is particularly linked to the nature of human beings. Human beings resist change. So obviously when you talk about implementing a solution, you are moving people away from what they know to a new thing, right? So a lot of change management is required in ensuring that you actually realize the objectives of the model or the solution that you're proposing. Excuse me. So implementation, so when you talk about the last step of the problem-solving process, then we are saying that implementation is the most difficult. Remember that implementation begins by deriving managerial insight from our modeling efforts, but framed in the context of the real-world problem we are solving. And apart from deriving those insights, you should also be able to communicate those insights so that those insights can influence the actions that you are proposing. So linked to implementation is communication. So let's not fall back and think that you develop a model that is looking nice, right? It's doing the job. Are you able to communicate the results of this model so that action, managerial action, can be influenced? That's why we say that implementation is one of the most difficult phases of the problem-solving framework. All right. In terms of implementation, then we see business analytics projects following a particular life cycle, and which can be subdivided into these 4 phases: project definition, invention, pilot testing, and business use. As we go through the various topics, as we go through the various modules, these various phases will become clearer. So obviously when you talk about project definition, this is critically aligned to the problem definition phase or problem identification, as well as the formulation of the problem. And some of the key activities in the project definition section of the life cycle is to understand who are the stakeholders of the project. Then remember that you need to partner with these stakeholders. If the stakeholders do not buy into the project, then you have failed from the beginning. So that's why we talk about partnering with stakeholders and the decision makers early on in the project, so that the actual scope of the project is understood and well defined, so that eventually you are able to maximize the impact of the modeling project. So partnering with stakeholders and decision makers is key early on in the project. The invention section of the life cycle focuses now on that modeling aspect, where you are analyzing the model, right? Deciding on what is the critical algorithm that is important for this particular situation. Establishing validation. Remember I talked about validity has to do with the model accurately representing reality. And that accuracy is only determined by the stakeholders. So the stakeholders must accept the model. So we talk about validation as a key aspect of the invention stage. The other aspect of invention is that because we're talking about modeling, you must be able to identify data that are relevant for the modeling process, and also to establish a business case for this particular issue. So we talk about proof of concept integration into business processes. And sometimes it may require the development of prototypes, especially if it is a computerized modeling solution. What is the prototype model that you then share with the stakeholders so that they can give you a go-ahead to proceed to the next phase or the other? This then moves the process to the pilot testing phase. And by the way, the invention and pilot testing are iterative, so you can move back and forth between invention and pilot testing. And lastly, in terms of the cycle, when you talk about business use, is you are integrating the model into the ongoing operations of the organization. So if the model cannot be used in the organization, then the project was useless in the first place. So can you implement or integrate the model with ongoing operations, right? The other aspect or activity is to provide training and ongoing support to the users of the model. Thirdly, to be able to share best practices. So the model may have been used in other industries, in other sectors, right? If it is being implemented for the first time in this organization, you need to share with them what are the best practices, for instance, of using this model that they are now implementing in the organization. And lastly, every modeling project must always must have a continuous improvement plan. It is not always excellent the first time you design it. And therefore, what is your continuous improvement strategy as you implement the model in the organization? All these are aspects of the business use aspect of modeling. Now, if you look below that framework, there are two other things that are considered to run in parallel, especially when you consider the sections of pilot testing and business use. The first one is that in this modeling project, sometimes there's need to productionize tools and data flows. That one of the outcomes of any modeling project could be to commercialize or to develop certain tools that can be generically used either in this organization or in different departments or in other organizations. That's why we talk about productionization. Can you commercialize some aspects of it, or can you make some aspects of it, some aspects of the tool that you've developed to be generic and can be used or replicated in other sections or other departments? Then you also have other parallel activities running, such as establishing proper security, training, help, and maintenance throughout the life cycle of the business analytics projects. And we see all these life cycle sections are well aligned to the different phases of the problem-solving framework that we have seen earlier. I think as we come to the end of this this lecture, it is also important to highlight some of the psychological issues that impact decision making. We cannot ignore this because remember, we are talking about computer modeling here, and we have emphasized that you cannot leave decision making to the computer. That's number one. On the other hand, even though we are relying on computer models, and we have said that computer models are scientific from the definition we saw earlier, we still have to consider that there are certain psychological influences on the decision maker that uses these models. There are two key psychological influences that we want to highlight. But in terms of background, let's note that models remember, can be used for structural aspects of decision problems. By structural aspects, we mean those aspects that can actually be systematically structured, and their functional relationship between the variables in the decision. So if you can, for example, if you don't have data on the variables, it means you cannot model that problem. If you have data or you understand the functional relationship, if you recall the different categories, it means you are able to model that particular problem. So obviously not all decision problems can be modeled in this way as we expose here in this business analytics subject. So other aspects therefore cannot be structured easily, which therefore require intuition or judgment. Yeah, but let's note that human judgment or intuition are not always rational. And that's why we emphasize that because of these psychological influences, there may be errors introduced in judgment, and these errors mostly stem from two psychological things. One is what we are calling anchoring effects, and the second one is what are known as the framing effects associated with decision problems. When you talk about anchoring problems, we are referring to those influences, particularly what we call trivial factors that influence initial thinking about a particular decision problem. That's why we say that, anchoring effects arise when trivial factors influence the initial thinking about a particular problem. And they are common in practice. And a common example that is normally given is, for example, if you ask a group of people to find the product of a series of numbers, for example, 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8, right? According to anchoring effect, we know psychologically that people are influenced by the first few numbers that they see. So when they see, if they're asked to determine the product and the series starts with 1, 2, 3, the numbers 1, 2, 3, 4 appear to be simple to the decision maker. So if you're given such a series of numbers, the decision maker will think that that product is much more simpler than the second series, where you have the series starting with 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Now, both the product of these two series is the same, but as a decision maker looks at these numbers, the second series presents bigger numbers and therefore psychologically scares the decision maker and thinks that the product of those series of numbers is different from the first one. And this is not true. We know that if you find the product is the same, the product of those two series is 40,320. But experiments that have been carried out, have established that most people think the first series is simpler compared to the second series. And that's why we have those median estimates indicating that, the first series is simpler than the second series. So anchoring is critical in modeling, that either what you're used to or what influences you first determines how you make the decision, right? So from those two series, we are seeing how the first 2, 3, 4 numbers of the series is influencing the orientation of the decision maker to think that the product of the first series is actually simpler than the second. Yet, this is not the case. The two series or the product of the two series provide the same answer. So anchoring effects has a key influence in decision makers. Maybe you can use an analogy, such as, many of you come from different cultures or you are from different races. Sometimes the way you have been brought up influences how you make decisions. Now, that culture, if that culture is influencing your decision making, then culture becomes an anchor. Whether it is good or bad, it is the anchoring effect that we are looking at here. So the culture may be an issue, race may be an issue in terms of how you have been brought up and how that is influencing your decision-making behavior. So then culture or race then becomes an anchor to how you make decisions. The second psychological issue in decision-making is what is known as the framing effect. In that, when you talk about framing, is that every decision problem has different alternatives, could have more than one alternative. And obviously those alternatives, decision makers denote their preference for particular alternatives. So that's why we talk about framing effects refer to how a decision maker views or perceives the alternatives in a decision problem. So for any particular decision problem, you will find that if you have two or three decision makers, they may go for a different alternative. Yet the information regarding the decision situation may be the same to all of them. Therefore, why do they choose a different option if the facts are the same? This is where we talk about framing effects. Their perception, which is psychological in nature, influences the kind of decision that they make, even though they have the same facts regarding the decision problem. So the example that we highlight here and in the next slides try to emphasize this framing effect. And we'll look at some of these examples as we go on. So as we look at business decision modeling, we need to be cognizant of the psychological influences on decision making, whether it is anchoring effects or whether it is framing effects. And as we go through the different techniques, some of these will come out so that we are able to illustrate better the meaning of anchoring as well as the meaning of framing in decision situations. So these examples that are highlighted capture this. The last thing that we want to look at in this lecture is how modeling affects decision making in terms of whether they are good or bad decisions and the outcomes arising from the decision made, whether it is a good decision or a bad decision. And we say this because we do not want to say that every computer model in the context of business analytics that we are focused on here results in good decision. Not necessarily. A model can be good, but can result in a bad outcome. Right? That's why we have that quadrant that tries to capture, outcomes in terms of quality as well as decision quality. So good decisions do not always lead to good outcomes, right? And that a structured modeling approach to decision making only helps us to make good decisions, but cannot guarantee good outcomes. It is important, it's useful to think about, various situations that where you have a good model, all right? So when it is a good model, where you make a good decision and the outcome is good, then we normally say that that was deserved success. So the model has done its work, the decision outcome was good, therefore it is deserved success. But sometimes you can make a good decision, in other words, the good decision arising from that model, which results in a bad outcome, right? And typically we talk about bad luck in such situations, that was just bad luck. You know that you made a good decision, but the outcome was bad. Is that bad luck? Can you think of scenarios where, you think, based on the facts that you have, that you made a good decision, but the outcome was bad, right? For instance, you may have decided, during the course of your studies, you decide, okay, I'm going to be studying 12 hours in a day, all right, so that I'm able to make improvements in my results. What if after this process and you do exams, the outcome is bad, a bad performance, right? This is what we just call bad luck, because there may be other variables that you did not take into account as you are making the decision to study for 12 hours. Did you study using the right books? Did you study using the right tools? All right. Were you aware of the scope of the examination that is going to be tested? So you may make a good decision in terms of studying, but there may be other facts that were not considered that result in a bad outcome. And therefore, we simply say, that is bad luck. Sometimes you're able to make a bad decision and then you get a good outcome. And there are situations like that. Can you imagine a situation where, the other day Trump was talking about that you can drink detergent and that can get rid of COVID. What if somebody actually did that and they got cured? Right? So it's a bad decision, but with a good outcome. That is what we call dumb luck. Right? So, and there are many people who take chances like that. They are making bad decisions, and sometimes, because we operate in a complex environment, sometimes the outcome is good, and therefore we simply call that dumb luck. And then lastly, you can make a bad decision with a bad outcome, and typically that is what is called poetic justice. You cannot make a bad decision and expect a good outcome. If you make a bad decision and get a bad outcome, then let it be poetic justice, and we want to avoid this. Computer modeling wants to ensure that the outcomes are good. So as much as possible, either a deserved success is much better in decision making. Therefore, the structured approach tries to make this probable as much as possible. So in summary, therefore, a good decision when you're looking at this slide is one that is in harmony with not only what you know, so you must have knowledge about the situation. It must also be in harmony with what you want, what you can do, and you must be committed to a particular goal. Sorry, to a particular goal that you have spelled out clearly. So this, as we do modeling, we need to be really realistic that they have their place, and you may have a good model, but the outcome may either be good or bad. And it is up to you, the decision maker, to understand or to investigate, why did I have a bad outcome? While based on the model, we made a good decision, the decision quality was good. Why are we getting a bad outcome? Was it bad luck? Right? But if you made a good decision and got a good outcome, then you deserve that success. So as we go through this course, our focus will be on the use of these business analytics techniques and how they can aid in the decision-making process. So sometimes whether you get a bad outcome is not linked to whether the modeling was poor or not. So this introduction will serve as the introduction to the course, introducing to the different aspects, understanding what modeling is, what computer models are, and the different categories of models that we have looked at that we are going to come across starting the next lecture. Thank you very much.